Hello, everybody, and welcome to today's presentation. Monoliths or microservices make both your domain. Brought to you by OutSystems. I'd like to introduce you to our presenter, Francisco Menendez. Francisco is an experienced lead architect with a demonstrated history of working in the computer software industry. Skilled in business analytics, enterprise software, enterprise architecture, agile methodologies, and databases. He is master focused in artificial intelligence and from INRIA.
Thank you, Billy. So, hello everybody. I'm really excited to do this presentation. And as you can see by the title, monoliths or microservices make both your domain. I'm trying to make a point that there is space for both strategies. So, Billy already introduced me. I'm currently the technical head of technical practices, architecture development at OutSystems. And for starters, I would like to know a little bit about the audience. So, Billy, can you push the poll about the audience role?
And here are the results.
Okay, great. So now that I have an idea of the audience, let me proceed. So what is the mission? I want to bring here some recommendations how to scale IT and continuously deliver through these microservices and monoliths strategies. And I will start by comparing both strategies, benefits and hurdles of each one. Then I will follow with introducing domain-driven design not only as a mean to drive decisions, but also to draw some best practices around these practices. And finally, I will make some recommendations regarding service composition to decrease the complexity of handling services. Okay, monoliths versus microservices. Nowadays, everyone wants to follow the hype of microservices, leaving monolithic architectures to the abandon like old medieval castles. The question is everyone aware of the trade-offs between benefits and hurdles? Well, there's no doubt about microservices' advantages. Improved modularity, abstraction of business capabilities is enforced, services are managed as products, not as projects. Light and ubiquitous communication is established, allows for stack independence and environmental isolation, which supports independent scale. And all this enables development autonomy, which leads to autonomous continuous integration and continuous delivery pipelines. Now, I would like to know how much of the audience has already experienced with microservices.
And here are the results.
Okay, 50-50. It's very well balanced. Okay, so the question is, have all the promises been fulfilled around microservices? And I see that 50% of the audience probably already knows some of the hurdles and some of the real promises and the real benefits. But so let's go over them. When you have a fragmented and multi-stack system, that comes with a price. And that's what we are developing when we adopt the fragmented microservice strategy. The first hurdle is that now you need to handle inter-process communication, which might bring network latency, network hiccups, and also some latency due to the data marshalling and unmarshalling across services. The second aspect is that now, as a consumer, you need to handle multiple transactions, because if you chain different services, they will be doing independent transactions, committing their own database transactions separately. This means that you have extra effort to develop a fault-tolerant system because you have to handle communication errors and be ready to retry if there's a communication error. And sometimes if a service produces an error, you have to undo the previous service call and in order to keep consistency. And this typically involves a lot of extra code and extra effort as a consumer. The third limitation is data mashup, because now you're limited to API calls. So you get customers from one service, you get orders from another service, and if you need to correlate customers and orders and somehow segment the list of mashed up information, you need to do it in memory because you have no access to the original data sources. Security is also another concern because now you have to manage credentials and access control across services. Debugging and troubleshooting becomes a nightmare. Sometimes a problem that surfaces in a certain service call, the root cause is deep inside the chain of services. And finally, monitoring and logging is another extra effort, because if you want to have effective monitoring and logging, you require a centralized services, and you have to have all your microservices communicating with that central service in order to have a centralized monitoring and logging. Well, after a length of service proliferation, what will happen is that if we report some cases, some ITs excessively adopting microservices soon found out that essential benefits of this architecture becomes actual burdens. Instead of enabling them to move faster, each team found himself mirrored in exploding complexity, and the cost of managing a global service catalog explodes. Is there a palliative to all this pain? Well, before I answer that, I would like to know which are the current technologies you are using in a daily basis.
And here are the results.
Okay, so Java takes the lead. Okay, thank you. Well, I was curious about what are you using, because I'm actually basing my presentation on my experience, but I'm also ready to, if any question arises, to talk about how to solve this in another type of approach. But going back to the list of problems or issues or hurdles that we identified before, one first recommendation would be to adopt a low-code platform, and I see that is still a minority of the audience already using a low-code platform. But the benefits here is that those three issues, security, debugging, troubleshooting, and monitoring, logging, they are handled automatically by the platform itself. So we only have to focus on the remaining four. Well, if we are not too fundamentalist, we can actually expose a query model. And I will elaborate a little bit more on this later. But this is not only easy in a local platform, but it's also possible in other technologies. So what I'm talking about here is that as a producer, not only I'm exposing a service API, but I'm exposing some public data view that allows my consumers to mash up information from different services, and even information mash up with its own information. Of course, in other technologies, this implies having a common database, at least for these query models. I will elaborate a little bit more later. But at this point, we still have to cope with these three remaining issues: inter-process communication, multiple transactions, and fault tolerance. And they come with some cost. So the question is when to adopt microservices, given that I have all this extra effort. Well, if we see how a software factory grows, when you start with a small application, and the applications grow themselves. And after a certain point, you start modularizing and scaling, and you end up having medium-sized applications with strong dependencies across themselves because they are reusing some modules or libraries in a strongly coupled way. And after a while, the strong reuses leads to a large monolith with supporting a portfolio of core systems, services, and applications, which then you will start feeling the degradation of maintainability, reliability, flexibility, so on and so forth. And the major pains is that deployment of a new version of a subpart of the system becomes way too complex due to all these dependencies and way too slow to move everything. And if you have different teams supporting, for instance, applications for different departments, the HR, marketing, and finance, teams will get entangled on each other. And at a certain point, you really need to decouple services in order to support independent teams. Of course, you should prevent this upfront and not only when everything is burning, but when you're starting, probably this is not your concern because you are still handling one or two teams, small portfolio, but you need to be ready for decoupling services at a certain point. Now, when you compare the benefits of monoliths versus microservices regarding deployment independency, scale independency, service communication, and transaction management, what comes up is that on one side, monoliths support simpler logic and faster development because everything is in the same processes. You don't need to handle different transactions. But on the other end, microservices have a better support to continuous integration, continuous delivery, independent pipelines, and better scale. So which one fits your needs? You probably need both advantages, right? So the question is how to balance both approaches. That's when I'm introducing domain-driven design. Domain-driven design is a methodology and process prescription for the development of complex systems whose focus is mapping business processes within a problem domain into the couple domains of technology artifacts. And the main objective or the main goal or the main benefit will be that it will support independent continuous integration, continuous delivery pipelines for different products and different teams. So what is depicted here is different domains. They are decoupled, so they have just these loosely coupled dependencies across each other. But internally, they have different paces, and they can even have their own small monoliths inside. So what are the principles in order to get correctly shaped independent domains? The first principle will be to group concepts by functional area or line of business. For instance, if in the same domain you try to solve business processes from marketing and business processes from human resources, you will not have such a stronger business fit and decision power. When you're trying to serve two different sponsors, then there will be conflicts in terms of decisions, right? So it's very important to nail a single functional area or line of business. The second principle is to dedicate a multidisciplinary team to that domain. This is sometimes very hard to implement when you already have a huge organization with a lot of teams that is not organized this way, because this implies changes and people are always resistant to change, breaking silos, so on and so forth. But this is what will not only promote ownership but also better control on your assets. And if you take into consideration, for instance, the Conway's law, which states that organizations tend to design solutions that reflect their communication structure, having an independent multidisciplinary team will benefit domain independence and promotes the design of light and well-defined interfaces, which leads to the third principle, which is the obvious one. You need to establish light and stable services interfaces for each domain in order to reduce impacts across domains. How does how do we map business concepts within this domain-driven design into IT concepts? So the main characteristic that we want to implement is to have independent life cycles, and this is supported by independent continuous integration, continuous delivery pipelines, which are typically supported by independent teams. Now, inside the domain, you have subparts. For instance, take the financial domain. You can have different processes, general ledger, purchasing, salaries. And these distinct processes, they might need some independence from each other, but here the independence is not as important as across domains, because now I'm inside the same domain managed by a single team, but I still need to promote different versions of different parts of my solution independently. So this leads to independent deployment units. And I will show later on what are the recommendations regarding the dependencies across these deployment units. Finally, each of these processes, they need concepts. Like for the salaries, you need to have implement the concept, an abstraction around the compensation, APIs around compensation, bonus, salary grid, so on and so forth. And this typically maps to your modules or libraries. Now, let me introduce two types of domains. I'm here calling these the vertical domains are the ones supporting a line of business. And for instance, marketing, finance, the human resources, you name it, right? And these vertical domains are the ones that you really need to make sure that they are independent, because they will have different sponsors, they will have different paces, and so on and so forth. On the other hand, you have horizontal domains, which are the ones supporting the foundations for this organization. They contain the most reusable services shared by multiple verticals. And the main difference here is the fact that while the vertical domains must be absolutely independent, in the foundation services, they tend to be governed by foundation teams, by IT teams. Sometimes the business verticals are supported by different teams. Sometimes you even just set a team just for a new version, you out-contract or something. But here, the foundation services are typically more strongly governed. So, as I will show later, we can trade off some independence across foundation services, across these horizontals, in order to decrease the complexity of managing, for instance, multiple transactions. So just keep in mind, on the verticals, I absolutely want them to be independent. On the horizontal level, there may be some trade-offs. Well, let me give you just an example coming from the insurance industry. So you could have all these vertical domains like the auto line of business, the health, the multi-risk, even the B2E broker portal area, it's another line of business. The B2C client website and client mobile application is another line of business. And you can have some core services supporting everything, like the service around insurance, CRM services, simulation services. You can have also common libraries to support the style guide or any kind of UI stuff or any plugins for mobile devices or whatever. So here we have the foundations, the common services, and these are all independent line of businesses. I want to retain the best of monoliths and microservices. So the principle here is that you should promote strong coupling inside a domain, because they are managed by the same team and will benefit tight processes that tend to be very complex inside a domain, because you will have in-process communication and you have a common database transactions with these monoliths. And again, you could have some independency across some of these subdomain parts, domain subparts, and but you can manage much easily manage those dependencies, because they are controlled by the same team, as long as you correctly isolate in your architecture the modules of each subdomain. And of course, here inside a domain, you could also have a foundation layer to support reusable stuff across your applications inside the domain. But again, this is easier to control because it's the same team. And actually, this is a criteria to split a domain. If at a certain point you have in this certain domain something that needs to be reused by other domains, that means that maybe you need to break your domain in two and isolate some microservice or some domain to provide services. Okay, now across domains, you really need to make sure that you just keep a loosely coupled reference across domains. And I'm introducing here two aspects of the domain API. So you have all the inside elements of the domain that are not visible from other domains, but you support somehow a domain API. And the domain API should support two parts. A query model, as I mentioned before. This will be read-only entities or read-only tables to allow consumers to list, search, or mesh up with other entities. I will go into details a little bit later. And also a service API to perform all the data transactions and retrieve details. Because query model is typically just for summary data that allows me to mesh up and list. But once for instance, if I want to mesh up customers with orders, I just need to summary. But once I need to handle a certain customer or a certain order, then I should fetch the details through some service API. Or if I need to make some change, there will be a data transaction through some service API. Now, the exception is this strongly coupled relation. Sometimes, and this is an exception, sometimes you might benefit of a stronger governance across two domains, but with this simplifying the need to handle multiple transactions and complex logics just to keep consistency, data consistency in your logic, so on and so forth. This is something that, depending on how tightly governed these teams are or the confidence that they have on each other, you might promote this type of exceptions sometimes, and it will save a lot of complexity. But these type of exceptions are not allowed with the vertical domains, or should not be allowed. Now, digging a little bit inside the domain architecture. So, as I said before, a domain has all these inside the elements that are not visible to the outside, and has its API, which is split in two parts, the service API and the query model. This is a little bit an adaptation of the CKRS pattern, Common and Query Responsibility Segregation. What happens is that spread across all your internal modules, you can have a lot of database definitions or even database tables, but they are only usable inside the domain. They support all domain transactions, business flows, internal business flows, internal state, and so they are not visible to other domains, and any change will only affect, any change on this common model will only affect the team inside that domain, or will only affect the assets inside the domain. On the other hand, you expose some public view with summary information that you want to expose to other domains. Now, depending on the technology, there's several ways to do this. What I'm trying to represent here is that since I'm doing all the transactions through my service API, every time this changes something, and this might be changing some control attributes that are not visible to the outside world, but if they change something that is exposed publicly, I should do the change immediately, or if this is just a view, then this is done automatically. But what I want to highlight here is the fact that I'm not talking about a complex synchronization of two different databases, because there are several ways to implement this. But the fact that I want to remark is that being a summary, and you should only make visible a summary of your information, because this only needs to support the listing and searching of objects. Being a summary, this doesn't change very often. For instance, if you have the name of a customer, the name will not change. But if you have the balance of that customer, then that's something that's probably not on the summary. It's on the detail. And if you keep this type of principle, it's not difficult to keep a query model, either through a view or even if you're replicating data to another database, which is in a public database accessible by everyone. By the way, in a low-code platform, this is very easy to implement. Now, the service API will support all the transactions and the retrieval of details. And you should adopt evolutionary design principles and only evolve your API with non-breaking changes on your signatures to reduce impacts across modules, across domains. With this approach, you ensure data isolation, you reinforce ownership, and you reduce impacts across domains. It's time for another poll. Are you working or envision to start working with microservice in the next 2 months?
And here are the results.
Okay, so the audience is really interested in using microservices. Okay, let me start by debunking the myth around microservices. So most of the audiences are probably already aware of all the principles laid down by Martin Fowler and James Lewis. But what I'm trying to say here, so I'm not going into details, what I'm trying to say here is that it's also all about perception, because every time I have a black box providing me a REST API or a SOAP API, I tend to consider that a microservice. I don't know if they are following all the microservice principles, but this is, for me, that's a microservice with different levels of compliance. And actually complying with all the principles, it depends on the value or the benefit that each principle brings. But basically what I'm trying to say is that every time you create a service application or a service, you provide a service API, you can comply, you can do, depending on the principles that you adopt, developing that service, you can do componentization via services, you can implement smart endpoints and dump pipes and don't use complex ESB, enterprise service buses. You should isolate concepts around business capabilities, you should design for failure, and you should promote evolutionary design. But once you adopt a domain strategy, you're adding the products, not projects, which is another principle. You're adding decentralized governance, and you're adding decentralized data management. And if you really want to follow all the principles, then you can also use technologies like containers to have infrastructure automation. If you place the assets of a domain in a container, or some parts of those assets, the ones that provide some service, you can actually cope with all the principles. But my message is also, don't be a fundamentalist and extend these principles with exposing also a stable query model. Service communication will benefit from this, not only because you're providing flexibility to your consumers, and another aspect that I did not mention before, which is a very significant aspect, is once you promote a query model, you will be simplifying your APIs, because now you don't need to be subject to all kind of demands from your consumers. Hey, give me customers, but only by region or by age or by any other criteria, because they have the query model, they can do whatever they want, which simplifies the communication across domains. So microservice principles plus data composition for rapid application development is very, very powerful. Now, service composition. Okay, now we have all these services, and I need to base my logic shading some of these different services, right? Let me take an example. So I have here in a horizontal domain, in a vertical domain, some process for, around customer acquisition. And I need to create a customer, and I'm calling one service. This will return me a GUID, and then I can create a contract for that customer, and then I can create an account, and all through different services. What happens is that now I have to manage to add extra, as a consumer, I need to add extra logic just to cope with consistency. If some of the calls fails, I need to undo contracts, I need to undo customers, and so on and so forth. And for me, this is not a correct abstraction, because I'm providing a service, but I'm also giving extra responsibility to my consumers to handle consistency and manage all this consistency. So one of the aspects that is very important is to provide the correct use cases. You need to provide APIs for the correct use cases. So if you merge all the services and provide single transactions, and in this example, all the services came from the same domain. So in this case, it's very easy, because now as a domain holder, if this is a common use case, I need to provide and do the composition myself. And since I'm strongly connected inside, I can provide a single transaction. And now I don't need to give this extra burden to my consumers. What if services belong to different domains? Then that's where that exception kicks in, because now I need to create some acquisition service in some domain. And if I do that exception of strongly coupling, which, by the way, is very easy to do in a local platform to take these two approaches, but even with a, I'm sorry, even in other platforms, there are means to do this, of course, with event management and more asynchronous ways. But the key message is that you should remove this responsibility from the consumers. And when we are in a domain-driven approach, when we are in a domain-driven approach, the verticals should not worry about those kind of concerns. And most of the times, even these horizontals, they might be some of the tactical departments or tactical solutions for some departments. They might be even being developed by citizen developers, and we don't want to give a lot of complexity to those vertical domains. So let me summarize the key ideas that I was trying to pass today. Adopt domain-driven design and be smart with your domain boundaries based on functional areas, CI/CD independence needs, and that will put you on the right track to cope with the balance between monoliths inside the domain and microservice strategy across domains. The second one is you should promote strong coupling inside a domain. And finally, loose coupling across domains, as I just mentioned. I concluded a little bit earlier, so we have more time for questions.
Awesome. We did have a couple questions come in. Also, audience, if you do have any questions, please post them into the questions panel. The first question we have is, what is a low-code platform, and can you provide any examples?
Okay. Well, obvious example, because as you see, I come from OutSystems, is the OutSystems platform. But in a low-code platform, there are several aspects. The idea is to ease the entire life cycle of an application, from development, from the deploying, testing, and so on and so forth. And it's strongly based on visual language. This doesn't mean that this is not for serious work. It's for very serious work. But what these languages try to accomplish is to make the design of logic, design of interfaces, design of the database design, database modeling, everything very visual and very close to definitions. So you will develop faster. But of course, that doesn't mean that it's solving everything for you. So, and the reason I'm saying this is that sometimes you have developers that are used to control everything at hard code level. those all your skills are required still, because you need to design algorithms, you need to model your database correctly, you need to design your logic correctly, but in a faster way. And these low-code platforms also provide support for all the deployment process. So putting everything together, deploying for quality, deploying for in production, everything is taken care and packaged all together, and all the aspects are taken care automatically. So the entire cycle from development, or even for changing some change request until that is in production, can take minutes with a low-code platform. Okay. The question was, what's a low-code platform? And if I could give an example, well, the best example I can give is the OutSystems platform.
Great. We do have another question that has came in. The question is, to avoid service composition at the consumer level, you mentioned that you should supply single transaction methods that match the use case. Mm-hmm. What if you need to compose those services from different platforms?
Okay, so let me take this image. Let's imagine that I want to create this composition, but these are coming from different platforms. So basically, what I don't have is this ability to do this strong coupling, right? In this case, in this type of scenarios, what you can do is you will base this in some in more asynchronous protocol. So instead, just imagine that everything is loosely coupled in this case, because these are from different platforms. And what will happen is that you will do a call, for instance, to create a customer. This will create a customer in a temporary state, because I don't know if everything else went well, but at least I get a GUID, then I create a contract, and I create an account. And then you have some event manager that allows you to publish events and subscribe events. For instance, if the account service later on ends up in an error or is accomplished successfully, the customer service will be subscribing to those events, and it can react, and later on it will update the customer itself, the customer state. So you need to implement more asynchronous processes, and either your end user application needs to be prepared for asynchronous processes. It's like if you're filling up a form in your application just to go through this process, it does not end immediately in success or failure. It ends up in an intermediate state, but every time you list that process, you can see the update on the state, or you could even subscribe an event from the customer service just to react to if something happened and you know that everything finished. But of course, you need to introduce these extra control mechanisms, and you typically need to go through asynchronous processes.
Awesome. Do you have a couple questions that came in? The next question is, what can I do if one service is missing or not accessed?
Or not accessible, or not, sorry?
Or not accessed.
I don't understand the last word, accessed.
Yes, or accessible.
Not accessible. Okay. Well, again, here that's where you need to add all this extra logic. And again, it goes through this asynchronous process. For instance, if in order to accomplish this process, I create a customer, then the contract somehow is not working right now, but the account does not depend on the contract. So the sequencing is something that either is mandatory, or you can cope with creating threads in parallel, launching the services, and recovering from and keep retrying something. For instance, if the contract service is not accessible or is producing an error, at least you know that the customer service, the customer is there, but is in a temporary state. It's not finished. The provisioning of the customer is not finished, and you need to keep retrying the contract itself. And that's extra logic again that you should abstract in this acquisition service. So this guy is the only one that needs to know about all this complexity, because again, the vertical domains consuming this, for them, they are just doing this provision customer, and they will be notified later on when everything is done, but they don't need to worry about retrying, so on and so forth. So that's why this orchestration is always important. And of course, if the services come from the same domain, this is easier. If they come from different domains, now again, in the local platform, you can do this exception, but in a multiple stack implementation, you need to add this extra control functionality, right? But what I'm trying to highlight is the fact that you should abstract. If you have you're creating the foundation of your software factory or to support your IT, your organization, you should most commonly reused services, they should be abstracted correctly with some orchestration, sometimes an extra service that will proxy to other services, but it will handle the complexity, and you leave this complexity out of the consumers.
Great. The next question that we have is, do you recommend HTTP communication between microservices or event-based communication?
Well, actually, I will recommend both, because they serve different purposes. So, and by HTTP, I am assuming that you're referring to even REST and SOAP, or well, you could have also HTTP calls and get answers on the answer, but and I'm not sure if that's what the question means, pure HTTP or just protocols on top of HTTP. But anyway, there are space for both, because, for instance, whenever I need to fire some transaction, it should be HTTP-like or a REST or SOAP like call. But events are very useful to support this consistency, because you always need to start stuff in temporary states, or because you want to lighten the dependency across services. So even as this service, they don't need to know about each other. If I have an event-based system where I can just publish events, I should not make direct, for instance, if the customer service needs to know if the account service is already accomplished, I should not send an event directly from the account to the customer, because now I'm creating a dependency. Of course, you could do that, but if you have an event manager where you just publish the event and the customer is interested, will subscribe to it. But the events themselves, they are very useful to regain consistency without strong dependency across services. But there's place for both. That's what I'm trying to say. They don't replace each other.
Awesome. Well, thank you, Francisco. That looks like all the questions that we currently have. So would you like to add anything before I close things out, Francisco?
Well, basically, I try to make my point that, like everything in life, there's always a balance, a trade-offs, and it's not always only one side. So in this case, it's not only microservices or only monoliths. And again, another balance is don't be too fundamentalist and just be fundamentalist around principles. I try to pass the message that augmenting the API with the query model will decrease immensely, and I had that experience many times, will decrease immensely the complexity of your architectures. And this can be implemented in different ways. Of course, with a local platform that will become easier, but even if in a multiple stack solution, you can always come up with some common database that supports this sharing of information.
Great. Well, Francisco, I would like to thank you for a great presentation today. I would also like to thank today's sponsor, OutSystems, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. I hope you learned something new that will help you in your developer career. Have a great day, and we will see you next time.
Thank you.